Hi, welcome back. So in this video, we're going to talk about ADSL. Okay, so ADSL is subject level information. So in this dataset, we'll be having all the related demographic information along with the treatment information and the population flag. So before we continue, let's go with ADAM implementation guideline. So similar like SDTM implementation guideline, in ADAM also we have ADAM implementation guidelines. If you check ADSL part, okay, like for example, you go to the content here. Okay, so first I need to talk about the classification of ADAM datasets. So there are three major classifications in ADAM datasets. So one is ADSL, which is subject level information, and the other one is BDS, basic data structures. It will have laboratory data, efficacy data, and time to event data. And the third one is occurrence data structure that have mostly events and has adverse events and concomitants. And we have other client specific ADAM datasets. So we don't go more for this one. We will be covering most of them in these three classifications. Okay, the ADAM ADSL is a subject level information. Let me open. Here is object. So it will be have mostly the general informations. Okay, so the ADSL variables will be having the identifiers like all the subject ID, unique subject ID, site ID. Then we'll be having the demographic variables. Then we'll be having that population indicators like full analysis set of population flag and some population flags per protocol population flag, randomization flag, enrollment flag, and we'll be having the treatment related information, the treatment 01 planned and treatment 01 planned in numeric format and actual related access represent 0102 in different periods, right? On, and we'll be having the treatment sequence and treatment sequence plan and treatment sequence actual ones, and then we'll be having grouping variables for the pool studies, pool treatments, and then we'll be having ADSL timing variables. Okay, so all this information we'll be getting from ADAM implementation guidelines. I'm using here is 1.1 version. There is a new version is available right now. You can refer that one as well. You can easily get from CD's website. Okay, let's continue with this one. We have ADSL specifications. So what I did, I just filtered out. So I remove I'll keep assign and derive and remove predecessor. So the predecessor is is nothing but it is coming from the directly from the DM SDTM dataset. So all these variables are coming directly from the DM dataset. So we don't need to derive these variables because this is already derived in DM dataset. Okay, so let's continue with we have to do with assign and derive ones the predecessor while removing that part. So we have almost like 10 to 15 variables to derive. So they are all of them are derived, and the two part of assign if it is the value is m, then we consider as the numeric as 1 because this is the numeric format integer type. Then we'll have race and as well also integer type and remaining all this. So we also getting some information because all the treatment related information we're getting from the exposure data set. Then height, weight, BMI, these ones we're getting from the vital signs because ADSL is a combination of, because we get the information from all the different hazards. Okay, so either from VS or LB or exposure, or sometimes we will be having disposition events. So we will consider all those things according to as per the specification required. Okay, so this is the header part. It will be this. It was a similar like how we did in SDTM part, and here we input is SDTM DM dataset. For all ADSL dataset, the input is SDTM datasets. So the output will be the ADSL datasets, and there is no macros was used, and this just modification is if your program is modified, you can give that date of the modification and who done the modification and the description of what the change has done. Okay, and then we continue with this programming part. So we're removing all the data sets. So this is if we have previous data set, we are kind of emptying those ones. So then we call library. We use control enter the deployer. We reading all those ones, and we set the working directory. So not here. Okay, so then we have taken, we don't need the raw data sets for now. So that's why I commented. I just took the SDTM dataset because we are reading all the SDTM datasets. The DM we are reading VS exposure and supplementary DM. Okay, supplementary DM So we'll be having two variables. Yes, so because there is a one syntax, there is a one operation was happened. Here is a pivot wider. The pivot wider and pivot longer. This both are works as the proc transpose in SAS, and this one I have explained in the previous class. So the pivot wider is basically if you have the rows, multiple columns, it comes to as a rows. So here we have considering the qnum and qval, the two variables. Let me show you how it looks before we run with proc transpose. So we have 10 variables here, right? So the qnum is the race other, and the qval is the value of that for this one. So what we're doing, the race other is coming because as per the specification, race OTH will be the our. So the race OTH is the variable name, so it has to come on the top. Okay. So for that reason, we need to transpose. We need to transpose by using the pivot wider. It comes on the top, and the value has to go on the bottom. Okay. So that's why I'm using pivot wider. ID calls based by unique subject IDs. There is only one record available, so we're considering only these two values. That's why it's coming as two variables. So the race other on coming on the top, and the white is as coming as the value for that particular subject. Okay, hope you understand. Then we merge with the DM dataset. So the DM dataset and the supplementary dataset we merge by unit subject ID. Then we have to do some filtrations by using the height and weight and BMI. We go to the distribution point here. Remove the PDSs. We don't need these PDSs. We have height, weight, BMI. So these ones we have to get it. We have to get it from the VS datasets. Okay, so in the VS datasets, when you check VS datasets, so these are given as VS test. We have height, weight, BMI, right? So we need to get those records first. Then we apply we rename as per the requirement of the specification. So let's start with HD. So this is the VS datasets, and HD is a new dataset we are going to create, and we are filtering out from VS test height. Then we're selecting use subject ID and the standard result numeric format and the standard result unit. Okay, so we are taking these parts. So we're selecting only three variables. So all these records are presented here is indicated for the height we are, because we filtered only for the height wall. Okay, so then we do the similar for the weight, we do it similar for the BMI. Then we do height to the numeric format of a standard result, like whatever height here. This one goes to the numeric result, and this one is height of the standard units. Okay, the height units. So I'm using part. Then I'm selecting the variables. Okay. Then the three variables. Then we do the similar for the weight and the BMI. So we have selected the BMI, weight. It will be the similar pattern. Now we want to merge these three, height one, weight one, BMI one, with the DM one here. Okay. So we have, before we merge, we have to before we join, we have to do a sort this one by using unique subject ID. Then we left join with the DM1 with the height here by unique subject ID. Then DM2 with the weight by unique subject ID. Then DM4 with the BMI1 by unique subject. Once we get DM4, so let's check here in the DM4. You will be having all that information, all those variables, height, weight, and BMI connecting, and even the race OT. There's only one record here. Okay, once we got these informations, then we continue with the exposure part. So you remember in our project, we'll be having two periods, the period 1 and period 2. So we need to get extract all that, because we need to allot the treatment information. Okay, so we need to get those information from the exposure. So EX datasets here. So EX dataset is group by unique subject ID. First, we have to group by unique subject ID. Then we have to do the first dot subject ID. It is a slice head is in our programming. It is similar like first dot subject unique subject ID in the SAS programming. So we considering only the first row, because when you check the EX dataset, okay, let me open the EX. So each subject has a two records, right? The first two records and second record. The first record will be indicated for the period 1, and second record will be indicated for the period 2. And S10, it has only one record because the subject doesn't have that period 2 treatment information. Okay, just to understand, for each individual subject will be having two records for period 1 and period 2. So now we are extracting period 1 separately and period 2 separately. So for that, we are considering the slice head n equal to 1 and ungroup, because after group by the unit subject, then we are ungrouping that subjects. Then we're considering only selecting those treatment related along with start date and end date, unit subject id, x those, and start date and end date. Okay, when you check this one, ex1, so you will be having all these records only for the period 1. Okay, period 1 related information. And when you come and you do the same thing with ex period 2, and but you have to take the last dot subject id here, slice hyphen tail, and here slice hyphen head. So these two functions would have to be use it in order to get those information. And here I am doing the renaming because the extrt is already there. It won't be overlap if we do like rename ex those two ex stdtc. So I'm doing it. Okay, so once we did ex1 and ex2, then we merge with the dm4. Okay, this one. So I have left join with the unit subject id with the dm5. So the dm5 will be having all the information related to height, weight, and related to exposure. Okay, exposure start date, exposure end date, and trt and trt. This is period 1 related treatment related information, and this is period 2 treatment related information. Okay, so next we will be continue with the assigning the treatment related information. So as per the protocol, the protocol will be having the treatment is oxybutynin. Okay, I don't see this information, but this is oxybutynin drug with the test, because the test, why we are giving the test here. So this is treatment 01 planned treatment, right? So we are considering the planned treatment. So arm cd is the mapping we have to map, because as per the specification, I don't see any information here. That's why I using from the SAP, because I don't have the SAP right now for my side. So okay, anyway, this is oxybutynin. Just imagine one drug, not been butynin. I just drug test, drug reference. Remember like that. So if you have in EX, let's check in EX. If you have REF reference, or in the DM5. So in ARM-CD, we have a sequence, right? Here we have RT or TR. There are two different sequence. So if it is TR, because this is 01 will be the period 1, and it comes as a test here. And if it is reference, and it will give you as a this indication. And if there is no sequence there, then we consider as a missing character format. So then if it will be the symbol like numeric format. If it is TR, we give as 1. If it is RT, this sequence, then we give as 2. And if it is missing, we give as an integer NA. Okay. And when you come to the treatment 2, period 2 informations, if it is TR, we give R, this part, not the period 1, not the test 1 here. So we give the test 1 here like that for period 2. Okay, and the PN will be having the same thing 1 and 2, and if it is missing, we will giving as a NA integer. So this is actual related treatment information for the period 1. If it is test, we give as oxybutynin test. If it is a ref, we give as a oxybutynin ref, and if it is missing, NA characters. So let's check here for EXTRT. So we have divided two treatments like EXTRT ref and test, and the EXTRT2, that is period 2 treatment related information. Okay, so we are doing based on that one. And EXTRT, if it is missing, we giving as a missing characters. And it is similar for the numeric format. If it is test, we give it as 1, and if it is ref, we give it as 2. And similarly for the period 2, if it is ref, we give as oxybutynin ref, and the test will be giving as oxybutynin test. And for the actual numeric format will be the same like period 1, and period 2 will be the same. So once we done these ones, then next we're gonna give the start dates of the treatment. So 01 will be the exposure start date, and 02 period start date is exposure start date 2, because we have derived, remember we have derived for the period 2 as we have period 2 we have given as exposure start date 2. Okay, then we execute this part, check. You go here, see treatment 01P have oxybutynin in ref, and 2 will be having like RT, TR, and the actual one also RT and TT. This is actual related treatment information. So once we're done, we'll be continue with other variables, which is sex and race. It is as per the specification here. If the sex equal to M, then sex N equal to 1. And if it is F, then we give it as a 2. And for the race numeric format, the race n 1, when the race is Asian, we give it as 1. When the race is other, we give it as 2. Okay, so we give the same thing. So remember, we'll be having double quotes, double equals here, and the tilde symbol when you are sending the value for the variable. So this is the variable we are creating. If you want to create this value for 1, if the sex is equal to M, then we give as 1, and if F, then we give as a 2. If it is missing, we give it as a NA, an integer format, because it's a numeric formats, right? And similarly for the race, if the for creating the race n variable, for the race, if it is Asian, we give as 1, and if it is other, we give as 2, and if it is missing, we give as a integer missing. Okay, so once we've done this one, we will be having the three population flags we have to create. So if not equal to, exdose is not equal to missing, and exposure started not equal to missing, then we give as Y. If there is a missing, then we give as no. That is for the safety population flag. And intended treatment flag, if armcd not equal to missing, then we give as Y for the randomization population. And if there is missing, then we give it as a no. So enrollment flag, if informed consent is not equal to missing, then we give as Y, and if it is missing, then we give as no. Because these three population, let me explain it clearly here. So the safety population is include subject who receive at least one dose of the study drug. Okay, so the person does not have missing for the exposure. If he has an exposure, does those subject won't cut in the safety population flag. So the subject should have at least one dose. So it should not be missing exposure start date and exposure dose. Okay, then the intended treatment is randomized subject. The population include all randomized subjects. So those are assigned for the treatment arm. So arm cd, if it is arm is given, that is there are randomized subjects are selected for the treatment. And the enrollment is the people who sign for the informed consent, all like enrolling for the clinical trials. So these are the difference between these three population flag. And once we're done, okay, so we have covered all these variables. So sex and race and safety population flag, and the treatment and treatment actual. Then we'll be having treatment SDT and treatment 2 SDT start dates, and we'll be having the height, weight units and BMI units. And the predecessor is automatically come from a DM datasets. Okay, predecessor variables, these are already derived. You see DM dot DM dot DM dot DM dot. So except sub DM QL, we already derive when we're doing this merging with the DM dataset with the supplementary DM, and these all dataset were coming from the DM dataset. Okay, so we have get all those variables, and we are selecting all those variables required as per the specification. Okay, so let's run the part. So after that, we are applying the label. So by using the var stat label here, and the C is because we are using the multiple variables. So for that reason, we have using variables. And then we have calling the H miscellaneous. So this is the library we're calling for to apply these labels to those variables. So for the final variable, call this one, apply this one. So this is ADSL will be the final one. See here. So all the treatment we have given the labels for these ones. Then once we got records, all the records, we save it as a final data set. So here, go to the atom, save it here. Yeah, ADSL, this is quite complex data set, because if you have a complex, because the project, this one, the project crossover study is quite easy forward, straightforward. That's the reason it won't have much complexity, but usually ADSL is more complex, because it has more data or more demographic, like population, safety population, treatment related, all those information. The study is more complex, this data set will be also be complicated. Okay, and this is a general way to derive a few variables. Hope you understand. Please let me know if you have any feedback. In case if you don't understand, please let me know by comments. Okay, we will continue for the other data set for tomorrow. Thank you so much for listening.